Good morning, or I don't know, good afternoon, ladies and gentlemen, friends, colleagues. I'm really happy to see all this here for this very informal webinar talk. So actually, this will not be just a webinar when I will make a kind of lecture and all people are listening for me. This will be more like discussion about what is capillary electrophoresis right now and what is the place for capillary electrophoresis in a series of analytical techniques. So you know that CE was born at about 30 years ago. CE is an abbreviation of capillary electrophoresis. So CE was born at about 30 years ago. And since then, it has developed, it has gained a huge popularity as a separation technique. And now it is used in a variety of different fields of analysis, from biotech research, university research, up to routine analysis for wine, beverages, water analysis, soil analysis, and so on and so on, any kind of environmental analysis, chemical analysis, and so on and so on. Yeah, so this could be really a very interesting choice if any analytical lab decides to get such an instrument, such a method, because actually this method can replace several older, let's say, methods, but it is not the only one. So the actual laboratory should have several techniques in order to cover all the possible applications, in order to get money, or in order to get projects, or in order to fulfill the requirements of their customers. So capillary electrophoresis is definitely one of the most powerful techniques which should present in each lab. Yeah. So I'm pretty sure that some of you, perhaps all of you, you have seen my webinars, you know about the capillary electrophoresis, so I will not show you all the presentations today. This is just, as you see on this slide, perhaps you see the list of industries and applications where capillary electrophoresis can be used, from, as I mentioned, from lung sciences to pharmaceuticals. And well, Lumeps is really very well-known companies all over the world. We have a lot of instruments and so on and so on. And here you see this is Capell instrument, Capell 205, and this is the instrument in which we realized capillary electrophoretic method as it is. Yeah. So let me now come more closer to the discussion. I know that many people ask the most important questions. What is the reproducibility of migration times in capillary electrophoresis? Because CE is a separation technique. You inject your complex solution in the capillary, then you apply high voltage, and then your components start moving along the capillary. That's clear, and they move with different velocities. And of course, in order to get reproducible results and rightly identified all the peaks, the reproducibility must be on the highest level ever possible. The reproducibility migration times. Yeah. So the people ask the question, what is about the reproducibility of the time? And there are rumors that this reproducibility is sometimes perhaps slightly worse than that of the HPLC or any kind of chromatography. I want to meet these concerns. The point is that everything depends upon the buffer which you use in the capillary. There are certain buffer additives which cover the inner surface of the capillary, thus to avoid any sorption of your substances to the capillary wall. Yeah, and if you use such an additives, we use it in many of our applications, in many of our recommendation buffers. So we have the reproducibility migration times on the very high level, let's say within 1 to 2% of RSD, which is really excellent. Besides, our software is so flexible that it helps to identify peaks correctly identify peaks, even if they were shifted to the shorter migration times or to the longer migration times a little bit, and it still can be identified with the software correctly. So this is the point. On the one side, once again, we use a lot of special additives, a lot of special precautions to avoid the migration time shift. On the other side, we have a powerful software technique which identified peak even if it was a little bit shifted. Okay, let me now meet another questions which very often pops out when we talk about the capillary electrophoresis. You know that general we announced two topics of today's discussion: capillary electrophoresis with a streaming potential control to increase the reproducibility, and capillary electrophoresis for the analysis of proteins, any kind of proteins. Let me talk now about the streaming potential, because the first question which I met was the reproducibility, and streaming potential is exactly the point which we use in order to increase this reproducibility. Streaming potential can measure, let's say, in general words, can measure the state of the surface of the capillary inside the capillary. The point is that from run to run, this surface, the state of the surface, must be absolutely similar to each other. Otherwise, we won't get the reproducible results. And with the help of measuring streaming potential, we can say whether the capillary is now in the same state as it was just in the previous run, or the state has been changed. And if it is changed, we use additional washing procedure, rinsing procedure, in order to put it in a necessary state. If it is in the same state, we just continue the analysis, and thus we get a very high reproducibility. I'm pretty sure that you know how it works, because you have used already, you have used the time to look at the presentation, but let me show you one example of analysis. For example, here, you see there are 3 traces of this electropherogram, and the difference, exactly the same buffer, exactly the same sample, why not? But the difference is that the capillary was not rinsed enough, means that the state of the capillary was different from run to run, and therefore you see we have irreproducibility in migration times. But this irreproducibility can be directly connected with the different values of streaming potential. You see it's on the upper trace, it is about 75 millivolts, and the bottom trace, it is 84 millivolts, and we can measure it. And if the software measures that the streaming potential now is a bit different from that it was on the previous run, then it gives the special order to the instrument to apply additional rinsing. And thus, after this rinsing, it measures again the streaming potential, and hopefully after the additional rinsing, it is the same as it was before, and then the analysis starts automatically. And then we do not have such a mess, which you see on this slide, where we have 3 analyses and they are different, not slightly, I would say, they are significantly different in migration times. Yeah. So this is what we do with the migration times separations. Exactly on the same slide, you see that the upper trace is with more contaminated capillary, and the bottom trace is with absolutely clean capillary. And this is the reason why in the upper trace there was a shift towards the longer migration time. And if you measure the streaming potential from the very beginning, you are able to say that, no, now I should not make the analysis because my capillary is still contaminated. I should rinse it more. And you understand, of course, that everything is implemented in the software, and what we are talking with you now about the decisions of the software, decisions of the operator, it is done automatically. So the software sees that the streaming potential value is different from the previous one, and starts rinsing scheme, additional rinsing scheme. And if now the streaming potential is okay, perfect, the analysis is starting. Yeah. So this is what we are talking when we are talking about the possible, I would say, possible issues with poor reproducibility migration times. This idea can be used, as you see on this slide, can be used in different areas. And first of all, let me put your attention to this point. It's here on the right side of the slide. It saves the long sequence of analysis if the capillary is contaminated after any of the runs. Imagine you programmed a long sequence of analysis for about 20 samples, and you put this sequence for overnight, yeah? And then you start the sequence of the runs, and you go back home. And when you come back in the morning, you expect that you get all the 20 analysis done in a perfect way. But imagine what happens if your sample number 5 is contaminated more than all other samples. So it means that the first 4 samples were run perfectly without any problems. Sample number 5 is contaminated. It contaminated also the capillary surface inside. And so this analysis is just a mess, but also all other analyses which are coming after the analysis of the sample number 5 are also a mess, because the capillary is still contaminated. And thus, instead of 20 analyses, you get just 4 analyses when you come back in the morning. In order to avoid such a very unpleasant situation, we use the streaming potential control, which immediately recognizes that the capillary is contaminated after the analysis of the sample number 5 and applies a special scheme of rinsing. And thus all other samples, all other analyses are saved. And when you come back, you see that only one sample is not analyzed in a proper way, sample number 5, but all other samples are saved. Well, you see that the situation is incomparable compared with the point when you have the sequence of analysis and you don't have the streaming potential control. That's clear. Yes, but it also can be used for many fundamental research like zeta potential determination, new coating designs, and so on and so on. Yeah, this is if we are talking shortly about the reproducibility and how we can get excellent results with reproducibility. Okay. Let me now cover some other questions which popped out for our webinar talk. For example, could it be possible to use streaming potential control when performing chiral C analysis? Definitely, yes, of course. The chiral analysis is a very important part of C analysis, and you use a special chiral additive to the buffer in order to separate isomers. D or L isomers, for example, optical isomers. It's even more important in this case because the chiral additive usually sticks to the capillary wall, changing electrosmotic flow drastically, and thus you need to pay special attention, to take a special care that the capillary state is the same from run to run. So SP can be very useful in this case. Another question pops out, is it possible to measure streaming potential coated capillaries? Yeah, but in coated capillaries, if electrosmotic flow is eliminated, streaming potential is equal to 0. So you measure that it is 0. It is also very interesting for the university research, for example, because people try to use a special coating. They try to design a special capillary coating, and they do not know whether this coating works perfectly or not. Means they do not know whether it eliminates electrosmotic flow completely or not. But moreover, they even do not know when this coating will start degrading slowly or rapidly, because nobody knows all of a sudden you get the results which are, let's say, not sufficient, and you don't know why, because of the sample or because of the coating, which are slowly degrading. If you measure streaming potential, you immediately see whether the streaming potential is still equal to 0, as it should be in coated capillaries, which eliminated electrosmotic flow, or it is now more than 0, or less than 0 if it is negative. Thus you understand whether the coating is slowly degrading. Okay. Well, this is about the streaming potential. Yeah. If we talk about another very scientifically rich, let's say, topic like analysis of proteins, sometimes, and also today, the people ask me about how it is possible to switch between different applications, generally between different applications. Yeah. So you have, for example, you have the analysis of DNA, RNA today, and tomorrow you wish to analyze proteins. So what should you do actually? Because it's clear that you should not use the same capillary, because to analyze proteins and to analyze DNA, RNA, oligonucleotides, you should use totally different buffers with totally different additives. In our system, it's very easy. In a Lumex CAP-LC system, it's very easy, because the capillary is packed in a special cartridge, we say it, or cassette, and what you need is to withdraw the cassette with the capillary cassette out from the instrument and to put another one. It takes you half a minute, and then you start another application without any problems. So it's really very easy to switch between applications. Another question is coming. If you use such a powerful mode of capillary electrophoresis, which is called capillary gel electrophoresis, which is used for analysis of proteins. And in this case, it is a kind of replacement from the very well-known SDS page gel electrophoresis, SDS polyacrylamide gel electrophoresis on a slab gel. This is the separation of proteins according to their molecular masses, and only according to molecular masses, so charges do not play any role. In this case, capillary is filled with a gel, and you can inject. That's very interesting option, actually, I would say. You can inject your sample from either of the capillary ends, from the inlet, from the left side, let's say, or from the outlet, from the right side. Yeah? And you know that the detector point is located in the capillary, not in the middle, but it's drastically shifted towards the outlet. What does it mean in reality? Imagine you have the capillary of about 30 centimeters length, and the detector point is located just 7 centimeters before the outlet. It means that the capillary is divided into two parts. One part is 23 centimeters from the inlet to the detector point. Another part is 7 centimeters from the detector point to the outlet. And you can inject your sample actually from any of these ends, from the inlet or from the outlet. Why? Because if you inject it as usually, normally, typically done from the inlet, from the left side, you have 23 centimeters effective length. And your separation of all the components of your sample occurs in this 23 centimeters. It's a very long distance, to be honest, and you need about 30 or even 40 minutes to get the full separations of up to 200 kilodaltons of your protein, or at least 160 kilodaltons of IgG. But you get a very nice separation, a very fine separation. Even small additives, small impurities can be resolved from the major peaks, because 23 centimeters is quite a long distance for such kind of separation. but it is for the price of the very long analysis time, up to 40 minutes. In order to make express analysis, you can inject from the outlet end of the capillary, and then you have only 7 centimeters to analyze all your sample, all components of your sample, sorry. In order to do this, you need only 12 minutes for the whole protein analysis. 12 minutes is nothing compared with the standard protein analysis and protein separations, yeah? So you use the short end of the capillary to analyze your proteins. You use very short analysis time, just 12 minutes, it's nothing. But of course, the resolution wouldn't be super excellent. But believe me, in many cases, you don't need to make a very fine separation. We definitely have a lot of very good separations, very good peaks, and perhaps I will show you now this separation, how it is done. Yep, and let me show you the folio, and this is like this. Just a second, I will show you everything. Yep, for example here, look on this slide. It's the same separation we have on the bottom part of the slide. We have a zoom of the what we see on the upper trace. It's a separation of the IgG protein under reduced conditions. We have light chain peak here, and we have heavy chain peak here. This is, as you know, about 23 kilodaltons, and this is about 55 kilodaltons. But also, with all these two major peaks, we have a lot of low or middle molecular weight impurities, like non-glycosylated heavy chain molecular weight impurities in the range of 43, 46 kilodaltons, a bit less, and so on and so on. So this, we use a very short capillary end. You see, the whole analysis is finished within, let's say, 11, 12 minutes, as I mentioned. But despite of the short time, we get very nice separation of all the components which were inside our protein sample. Yeah. So yeah, this is very shortly about the CG, and also the protein analysis. Let me have a look on another question which might appear here. I'm from the university and I would need this instrument for method development. Can I use couplers for it's highly dedicated only for capillary gel electrophoresis? No. That's the question which very often pops up. The people ask us whether our machine is a universal machine or it is highly dedicated only for the analysis of certain type of components. I would say definitely that our machine is universal capillary electrophoresis machine. It can analyze everything which actually can be theoretically analyzed by capillary electrophoresis, not only proteins, not only cations or anions, not only urine can be analyzed, or blood, or saliva, or whatever, any kind of biological liquids, any kind of environmental probes, and so on and so on. It is a universal machine. Everything can be analyzed, which is actually can be analyzed by CE. Yeah. This has very big advantage. The main advantage is that you can use one instrument from us for very different types of analysis. Indeed, it could be very different. Imagine if today you analyze recombinant proteins and tomorrow you analyze biological fluids, and the day after tomorrow you analyze environmental samples like soil or plant tissues or wine or any kind of water. So you see, to my mind, I'm very deeply inside the capillary electrophoresis history of the problem since 1990. I was involved already in this point, and I worked in different parts of the world with capillary electrophoresis, and I'm quite experienced in this field. So I can tell you that definitely this technique has gained a huge popularity, and has occupied already a very certain and a very definitive niche in the numbers in the sequence of separation techniques. And of course, I will be glad if it will be further spread throughout the globe, because it's a very powerful technique, it's very simple technique, it's very easy to understand technique. This is also very important. If you take a machine like we have, capillary electrophoresis, and any other kind of separation technique like, I don't know, HPLC, the easiness, the simplicity is uncomparable. You can easily start working with C, and unfortunately, this is not the case when we talk about the chromatography. It's much more complicated technique. So in C, and what is important, in C, the cost of your possible mistake is very low. Imagine what happens if all of a sudden you spoil the column in HPLC, in chromatography. If you spoil the column, it means that you threw away about $2,000, which is actually good money. If you spoil the capillary in the capillary electrophoresis, first of all, you can easily wash it with certain solutions, first of all, with a highly concentrated sodium hydroxide. But even if it is spoiled to the point that you cannot save it anymore, you simply throw it away and take another capillary. And it costs almost nothing, because about 10 meters of the capillary costs you about $150. And 10 meters is enough for the next century of all these separations, because one capillary cassette has a capillary of about 50 or maximum 60 centimeters length. So it's nothing, even, really nothing, even if you spoil the capillary. Okay. So this is very shortly which I wanted to tell you about the capillary electrophoresis and its place in the modern analytical techniques. I invite you kindly to have a look on my webinars about different fields. If you go to our main site, lumexinstruments.com, you can get more webinars from me and also some promo films about the use of CALPEL 205 system in different fields of analysis. And yeah, you are ready to type any type of question if you wish, or if it is finished, we can finish our discussion. Thank you very much. Thank you, Caroline.
Thank you, Vadim. I believe that now we can open for questions. If you have questions, you can write to us in English, in Spanish, or Portuguese. And if your questions are not in English, I can translate them and I can have Vadim commenting for us. So please bring us your questions. We'll be glad to answer them.
Okay, I see one of the questions here. In a seawater analysis, could the amount of sodium chloride mask other ions, disabling their analysis? This type of sample should be pre-treated prior to analysis. It's a good question. Thank you very much. I should tell you yes and no, because each method has its certain limitations. That's clear. That's clear. Yeah. And I guess this question comes from Brazil, because we have an instrument in Brazil, in Rio de Janeiro, in the university, and the people there, they analyze seawater, ocean water as well. We have several customers in different parts of the world who are dealing actually with the analysis of the water, in which one of the components, like sodium chloride, for example, present in a very high proportion, very high amount. Yes, it can mask other anions if nothing is done to pre-treat the sample. But what the pre-treatment means, in most of cases, believe me, what you need is to dilute it properly. We analyze so-called ocean water, seawater, and also oil-filled water. The special type of water containing certain salts, which is pumped inside the oil well in order to get more oil out from the ground. It's more or less the same complexity compared with the ocean water. It's even more dirty because it contains parts of the oil. If you dilute the ocean water properly, let's say, as far as I remember, we did it for about 500 times, then you get a huge peak of chloride when you analyze anions. Sorry, you get a huge peak of chloride when you analyze the ions, but also you still get small peaks of other components, for example, bromide, which you also can find in ocean water. Sulfate, definitely can find it there. Probably phosphate as well. They're very small, these peaks, compared with the peak of sodium chloride, compared with the peak of chloride, sorry. But to my experience, at least, we managed to analyze small impurities in the ocean water, even when the ratio between chloride and, for example, nitrate was 5,000 to 1. Can you imagine? 5,000 to 1. This is simply because of two things. First, robustness of our system. The system is indeed very robust and can survive even if you put inside a very highly concentrated, chloride concentrated water. And the second reason is the unique sensitivity of our system. For example, in Argentina, in several universities, people use our instrument in a comparison project with other CE manufacturers, and they realized that the sensitivity of Capel system is on enormously high level, down to low ppb level, points per billion. So it's nanogram per mil. And this helps us to get not only the peak of chloride, which is present in huge amounts, but also the peaks of very minor impurities like bromide or nitrates. So yeah, once again, 5,000 to 1, this is the ratio which we can still measure in ocean water between chlorides and other small components. I hope I answered this question. Okay, Caroline.
I believe we have more questions. Please, we were waiting for more questions. Do you have?
Okay, I see another question which pops up. Could Capel 105M and Capel 205 to be coupled with other analytical instruments such as mass spectrometry? If so, could you give us examples of actual cases, Marks? Could you give examples of actual cases or marks where such coupling could be possible? We have several examples of such coupling with MS. For example, we have a customer in the University of Ottawa in Canada, where the guys managed to couple Capel 205 with MS detector using the special interface. We have a special application note about this, and please ask me later. I will send you this application note directly. But I must tell you that officially this is not supported by the manufacturer. It means that you can do it, definitely, because it is done, and it was done in several places where people have our Capel systems. But it is not, once again, provided and supported officially by the Lumex Instruments group of companies. But it is possible. Okay, thank you. Okay, another question is coming. Which pharmaceutical standards that those instruments follow? This is actually a good question. I will try to show you what we have here. Just a second. I will show you what we have. No, it's here. It's another part. Yep. First of all, we have recommendations of World Health Organization, as you see, which officially recommends to use capillary electrophoresis for the analysis of some protein conjugates. Okay, first. Next, we have a special general chapter in the European Pharmacopoeia, and the same as in United States Pharmacopoeia and British Pharmacopoeia as well, which tells us that the CE is a generally recognized method for the using in the pharmaceutical industry. Right now, there are several separated articles how these components like somatropin, erythropoietin, whatsoever, can be analyzed using capillary electrophoresis. So I would say it should be analyzed by capillary electrophoresis according to the prescriptions of European Pharmacopoeia. Yeah. Another point is United States Pharmacopoeia. And about a year ago, a new chapter appeared, chapter 129, Analytical Procedures for Recombinant Therapeutic Monoclonal Antibodies. And this chapter tells us that such kind of IgG, so monoclonal antibodies, must be analyzed with the help of CE. And we fully meet the requirements of this chapter. So if you take our CAPEL system, it can fulfill all the requirements of the United States Pharmacopoeia, chapter 129. Last week, I have come back from the installation of this instrument in one of the big pharmaceutical company in Portugal, in the city of Porto, where people purchased CAPEL specially for the analysis of monoclonal antibodies. Several big biopharmaceutical companies in the world, like, for example, Boehringer Ingelheim in Vienna in Austria, or BASF in Mannheim, Ludwigshafen in Germany, they are our customers, and they use CAPEL systems to analyze these therapeutic recombinant monoclonal antibodies. So as you see, all the necessary standards are fulfilled, and the people use our instrument for the pharmaceutical analysis. Thank you. I hope I met this question. Thank you, Daniela. Another question pops up. How to guarantee the quality of your rinse without the use of streaming potential control? There is no any guarantee. Nobody can speak about the warranty. Yeah. It is a common sense. We say that if we rinse the capillary with a sodium hydroxide for a couple of minutes, and then with water for just 1-2 minutes, and then with running buffer for 2, 3, 5 minutes, we are on the safe side, and we manage to rinse the capillary completely. Indeed, it helps. Such way of rinsing in many cases, it helps. But if you deal with, if you want to shorten the total analysis time, you might understand that the analysis generally consists of several stages. You rinse the capillary once with solution, you rinse the capillary with another solution, you rinse the capillary with a third solution, then you inject your sample, then you apply the high voltage in order to provide run, and then finally you get your results. So it's 5 stages. And if you want to save the time, sometimes you avoid rinsing the capillary with the sodium hydroxide every time between analysis, and you rinse the capillary only with a buffer, which in turn sometimes can be not sufficient. And in order to be on the safe side, once again, you need to wash it with the sodium hydroxide always. But if you want to save the time, you don't do it. And then you need a streaming potential to be absolutely sure that even if you rinse the capillary just with a buffer between analysis, it is still enough to make analysis. If not, then either you need to wash it with a sodium hydroxide always, or you need to apply streaming potential. I think I made the question. Thank you, Caroline. The question comes, do we have kits for protein separation? Yes, for the capillary gel electrophoresis, we have kits like here you see, and also for the capillary isoelectric focusing, we have kits for the analysis. Okay, thank you. Okay, another question. The question pops how to improve the reproducibility in CE. I already discussed this point several times. We can do it either by using the special rinsing scheme, washing with sodium hydroxide, hydrochloric acid, water, buffer for a long time, or we can apply streaming potential in order to control the inner surface of the capillary. Thank you.
Any other questions that we can receive from our invitees?
Okay, if there's no more questions, probably Caroline, we can stop the discussion already. We can finish the discussion, and I hope that it was useful for everybody watching us and hearing us. And I'm always free to discuss any other points. Just send me a message or send me a message to the moderator, also to Caroline, and we will talk in more details about this or that issues. There is a question, can we send you the presentations? Yes, we can send you the presentation. I will convert it into PDF file and will definitely send it to you. Please provide us with your email accounts. Thank you.